What if the DNA of ancient Greece revealed a story far more complex than the myths, pointing not just to Athens and Sparta, but to the plains of Anatolia and the vast Eurasian steppe, proving that the first Greeks were migrants? The story of Greek DNA begins not in the shadow of the Acropolis or on the sun-drenched shores of the Aegean, but thousands of years earlier and hundreds of miles to the east, on the fertile plains of Anatolia. For millennia, the lands that would become Greece were sparsely populated by Mesolithic hunter-gatherers, small, mobile bands whose genetic legacy in the modern population is surprisingly faint, almost spectral. The great turning point, the foundational event that would pour the genetic bedrock of Greece, was the Neolithic Revolution. Around 9,000 years ago, a profound transformation was occurring in Western Asia, where communities had mastered the domestication of plants like einkorn wheat, emmer, barley and lentils, and animals such as goats, sheep, pigs and cattle. This agricultural package was not merely a new set of tools. It was a catalyst for a complete societal restructuring, enabling settled life, population growth, and the development of complex social structures. It was this revolutionary culture that began to expand, and its pioneers were the first farmers of Anatolia. Genetic studies, spearheaded by researchers analyzing ancient DNA extracted from skeletons at Neolithic sites across Greece, have painted a vivid picture of this migration. The evidence is overwhelming. The first farming communities that appeared in Greece around 6,500 BCE were not local hunter-gatherers who had simply adopted new ideas. They were a distinct population of migrants who brought their entire way of life with them. Analysis of remains from key sites like the Franchthai cave in the Peloponnese, which shows a clear stratigraphic break between the Mesolithic and Neolithic layers, and the well-preserved settlements of Sesklo and Demyni in Thessaly, reveals a dominant genetic signature directly linked to contemporaneous populations in western Anatolia. These early Greek farmers carried specific Y chromosome haplogroups, notably G2A, and mitochondrial DNA lineages that were common in Anatolia but virtually absent in the preceding Mesolithic peoples of Europe. This genetic data corroborates the archaeological record, which shows the sudden appearance of characteristic Neolithic artifacts: rectangular mud brick houses, polished stone tools, distinctive pottery styles, such as impressed ware, and the iconic seated female figurines thought to represent fertility deities. The migration itself was likely not a single massive wave but a series of movements, a leapfrogging process along the coastlines of the Aegean. These early agriculturalists, possessing advanced maritime skills, would have island-hopped from Anatolia, establishing small coastal settlements and gradually moving inland, following fertile river valleys. Their impact was transformative and total. They cleared forests to create fields, introduced new flora and fauna that permanently altered the ecology, and established the first villages that would lay the groundwork for all subsequent civilizations in the region. The existing hunter-gatherer populations were largely displaced or assimilated, their genetic contribution diluted to near insignificance by the sheer demographic success of the newcomers. The farmers' diet, rich in cereals and dairy, allowed for higher population densities and a more rapid rate of reproduction, fueling their expansion across the Greek mainland and islands. This initial genetic template, overwhelmingly of Anatolian farmer origin, became the foundational layer upon which all subsequent chapters of Greek history would be written. It was a heritage of innovation, of resilience, and of a fundamental connection to the lands of the East. A connection that predated the Trojan War by millennia and established that the very first Greeks, in a biological sense, were pioneers from across the Aegean, carrying the seeds of a new world. This deep ancestral root explains the underlying genetic continuity that scientists observe in the region, a baseline signature that has persisted through the rise and fall of empires, demonstrating that the agricultural revolution was not just a cultural shift but the primary demographic event that shaped the Hellenic world. Long before the sagas of Achilles and Odysseus, a brilliant and enigmatic civilization flourished on the island of Crete, leaving behind a legacy of labyrinthine palaces, vibrant frescoes, and a script that remained undeciphered for millennia. This was the world of the Minoans, Europe's first advanced Bronze Age civilization, which emerged around 3000 BCE. For over a century, since the excavations by Sir Arthur Evans at Knossos, the origins of this remarkable culture have been shrouded in mystery and debate. Evans himself, struck by the sophistication of Minoan art and architecture, which seemed to lack clear local antecedents, proposed an origin outside the Aegean, suggesting a migration of elites from the older and more established civilization of Egypt. Others looked to the Near East, pointing to similarities in religious symbolism and trade connections. The Minoans seem to have sprung into existence, their sudden cultural blossoming a puzzle that archaeology alone could not solve. It was ancient DNA that finally provided the key to unlocking this mystery, and the answer it revealed was both surprising and profound. The Minoans were not foreign invaders or colonists, but were instead the direct descendants of the very first Neolithic farmers who had settled the island some 4,000 years earlier. A landmark study analyzing mitochondrial DNA from well-preserved skeletons found in a cave ossuary at Hagios Chorolombos on Crete's Lassithai Plateau, dating back nearly 4,000 years to the heart of the Minoan period, delivered a clear verdict. The genetic signatures of these ancient Minoans showed the strongest affinity not with populations from North Africa or the Levant, but with Neolithic and modern European populations, and most critically, with the skeletal remains of the first farmers who had arrived on Crete from Anatolia around 7000 BCE. This discovery fundamentally reframed our understanding of Minoan civilization. It was not an import, but a homegrown phenomenon, a spectacular cultural efflorescence that grew organically from the deep roots of the island's own Neolithic past. The same Anatolian farming population that had settled the Greek mainland had also colonized Crete, and over millennia of relative isolation, their descendants developed a uniquely complex and sophisticated society. The genetic evidence suggests a remarkable continuity spanning thousands of years, from the first humble farming villages to the construction of the grand palaces at Knossos, Phaistos, and Malea. This isolation, however, was not absolute. While the core of the Minoan gene pool was derived from these Anatolian pioneers, further detailed genomic studies have identified subtle but significant influences from the East, particularly from Anatolia and the Caucasus region, that occurred during the Bronze Age. This suggests that the rise of Minoan civilization was fueled not just by local development, but also by ongoing networks of trade and migration across the eastern Mediterranean. Crete's strategic position made it a nexus for maritime exchange, and it appears this cultural and economic interaction was accompanied by a degree of genetic interchange, enriching the local population with new lineages. The Minoan DNA tells a story of a people deeply rooted in their Aegean homeland, yet simultaneously connected to the wider world. They were the children of the first farmers, who, empowered by their island environment and their mastery of the sea, forged a unique cultural identity that would leave an indelible mark on the later Mycenaean and classical Greek worlds. The echoes of their genetic legacy are still present today. The analysis showed that modern inhabitants of the Lassithi Plateau share a significant degree of maternal ancestry with the ancient Minoans, making them living repositories of this 4,000-year-old heritage. The mystery was solved. The Minoans were not foreign transplants, but the brilliant culmination of a long local journey that began with a canoe full of farmers crossing the sea from Anatolia. If the Minoans represent the blossoming of a sophisticated seafaring culture from Neolithic roots, the Mycenaeans represent a dramatic and transformative new chapter in Greek history, one marked by fortified citadels, warrior kings, and the thunderous arrival of a new people from the north. Emerging on the Greek mainland around 1700 BCE, the Mycenaean Civilization, named for its greatest center at Mycenae, was starkly different from its Cretan contemporary. Its art was dominated by scenes of warfare and hunting, its architecture by massive cyclopean walls, and its society was organized around a hierarchical, militaristic elite. For decades, the relationship between the Minoans and Mycenaeans was debated. Were the Mycenaeans simply mainlanders who adopted Minoan culture, or were they a new people who conquered the region? Ancient DNA has provided a definitive and revolutionary answer, revealing that the Mycenaeans were a people of dual ancestry, a composite population formed by the fusion of the indigenous Aegean people, the descendants of the Anatolian farmers and their Minoan cousins, with a new wave of migrants arriving from the vast grasslands of the Pontic-Caspian steppe, a region spanning modern-day Ukraine and southern Russia. This finding connects the origins of the Greeks to one of the most significant migratory events in human history: the expansion of the Yamnaya people and their descendants. These steppe pastoralists, who had domesticated the horse and invented the wheeled chariot, began a massive westward expansion around 3000 BCE. They carried a distinct genetic signature, primarily associated with a Y chromosome haplogroup R1b, and are believed to have spoken a form of Proto-Indo-European, the ancestral tongue of most modern European languages, including Greek. Analysis of DNA from the remains of Mycenaean elites, excavated from the iconic shaft graves at Mycenae and other sites across the Peloponnese, revealed this crucial genetic admixture. While roughly 3/4 of their ancestry traced back to the established Anatolian farmer/Minoan stock, a critical new component, accounting for at least 10 to 15% of their DNA, was unequivocally linked to this northern steppe source. This was the smoking gun that linguists and archaeologists had long sought. It provided a biological mechanism for the arrival of the Greek language in the Aegean, carried by these Proto-Greek-speaking migrants from the north. The fusion of these two populations, the established agriculturally advanced Aegean people and the mobile militaristic steppe warriors, created the unique cultural and genetic synthesis that was Mycenaean civilization. This genetic blend is reflected in their culture. They adopted and adapted Minoan art, bureaucracy, as seen in the Linear B script, an early form of Greek, and naval technology, but infused it with their own warrior ethos, mainland political structures, and Indo-European language. The genetic evidence suggests that this was not a simple replacement event, but a complex process of admixture that likely occurred over several generations. The arrival of the steppe peoples may not have been a single violent invasion, but a series of migrations that led to the gradual rise of a new warrior aristocracy that integrated with, and ultimately dominated, the existing population. This new ruling class, with its dual heritage, established powerful palatial states at Mycenae, Pylos, Thebes, and Tiryns, creating the legendary world immortalized in Homer's Iliad and Odyssey. The discovery of this steppe ancestry fundamentally reshapes our understanding of Greek origins, confirming that the Hellenic identity was forged from the meeting of two worlds: the ancient, sophisticated Aegean civilization and the dynamic, expansive peoples of the Eurasian steppe. It proves that the Mycenaeans, the first people to speak and write the Greek language, were themselves a product of migration and admixture, a powerful testament to the idea that Greek civilization was never a monolithic or static entity, but was forged in a crucible of cultural and genetic interaction from its very inception. Following the spectacular collapse of the Mycenaean palatial centers around 1200 BCE, Greece plunged into a period of profound disruption and decline known as the Greek Dark Age. The great citadels were abandoned, the complex bureaucracy of linear vanished, long-distance trade routes withered, and writing itself was lost for several centuries. This enigmatic period has long posed a major question for historians and archaeologists. What happened to the people? Did the population suffer a catastrophic collapse, a demographic bottleneck that nearly wiped the slate clean? Or was this primarily a societal transformation, a political and economic restructuring that left the underlying population largely intact? The traditional narrative, partly inspired by later Greek legends of the Dorian invasion, posited that a new wave of northern Greek-speaking tribes swept down from the mountainous regions of Epirus and Macedonia, conquering the Mycenaean heartlands and displacing or subjugating the existing inhabitants. This invasion was thought to have been a violent and disruptive event, responsible for the destruction of the palaces and the onset of centuries of poverty and isolation. For years, this theory provided a convenient explanation for the cultural rupture seen in the archaeological record. However, the advent of large-scale ancient DNA studies has allowed scientists to test this hypothesis directly, and the results have been astonishing, forcing a complete re-evaluation of this pivotal period. By sequencing the genomes of individuals who lived during the Iron Age, the period following the Dark Age, and comparing them to those of the preceding Mycenaeans and the succeeding Classical Greeks, researchers have found no evidence of a massive, demographically significant migration from the north. The genetic profile of the Iron Age population in the Peloponnese and central Greece is remarkably similar to that of the Mycenaeans who lived there before the collapse. There is no major new ancestral component appearing in their DNA that would correspond to a large-scale Dorian influx. This suggests that while the Mycenaean political and economic system imploded, the people themselves largely remained. The story of the Dark Age, then, is not one of population replacement, but of remarkable population continuity through a period of immense societal stress. The collapse was a failure of the elite-run palatial system, not a demographic wipeout. The complex, centralized redistribution economy of the palaces, which controlled the production and trade of bronze, textiles, and agricultural goods, proved fragile. When it broke down, perhaps due to a combination of internal strife, climate change-induced famine, and disruption of trade by the sea peoples across the Mediterranean, the entire edifice of Mycenaean civilization came crashing down. In its wake, society reverted to a simpler, more localized, and more rural existence. People abandoned the vulnerable urban centers and returned to smaller, self-sufficient farming villages. The population may have decreased due to famine and conflict, and there was certainly significant internal migration as people sought security, but the fundamental gene pool of southern Greece persisted. The Dorian invasion may not have been a myth entirely, but it was likely not the massive folk wandering once imagined. It might represent the rise to prominence of a previously marginal dialect group of Greek speakers, or smaller-scale movements of people that were culturally significant but not genetically transformative on a large scale. The genetic evidence forces us to see the Dark Age not as an ending, but as a period of radical decentralization and reorganization, a painful but necessary transition that ultimately paved the way for the rise of a new social and political structure, the polis or city-state, which would define the subsequent Archaic and Classical periods. It demonstrates the profound resilience of the Greek people, whose genetic heritage, forged from the Neolithic and Bronze Age migrations, proved strong enough to weather the storm of civilizational collapse and re-emerge, centuries later, to build a new world on the ruins of the old. The dawn of the Classical Age in the 5th century BCE marks the zenith of ancient Greek civilization, a period of unparalleled achievements in philosophy, art, drama, science, and politics, centered on the ascendant city-state of Athens. This was the era of Pericles, Socrates, and the Parthenon, a time when Greek culture solidified its identity and projected its influence across the Mediterranean. A central question for geneticists is whether this cultural explosion was accompanied by significant demographic shifts. Did the rise of Athens as an imperial power and the constant churn of trade, colonization, and warfare fundamentally alter the genetic landscape established in the Bronze and Iron Ages? By analyzing DNA from individuals buried in Athens and other parts of the Greek world during the Classical period, scientists have been able to construct a detailed genomic portrait of the people who built this extraordinary civilization. The results reveal a picture of deep-seated continuity, confirming that the Athenians who debated in the Agora and the Spartans who trained in the Agoge were, by and large, the direct descendants of the same populations that had inhabited Greece for the previous 1,000 years. Their DNA shows the familiar blend of the three core ancestral components: the foundational layer from Anatolian Neolithic farmers, the Bronze Age contribution from the Eastern Mediterranean, Minoan-like ancestry, and the crucial infusion of steppe pastoralist DNA from the north that arrived with the Mycenaeans. This underlying genetic stability suggests that the classical flourishing was primarily a cultural and political phenomenon, not the result of a new, large-scale migration. However, this period of intense interaction and mobility was not without its genetic impact. While the core ancestry remained stable, the DNA of classical Greeks shows subtle signs of increasing admixture and diversity, reflecting the interconnectedness of their world. Athens, in particular, as a bustling cosmopolitan hub and the center of a maritime empire, drew people from all corners of the Aegean and beyond. The city's port at Piraeus was a melting pot of sailors, merchants, artisans, and slaves from Ionia, western Anatolia, the Black Sea colonies, Egypt, and the Levant. This is visible in the genome as a slight uptick in genetic signatures from these regions compared to the preceding Iron Age. The DNA of a woman buried near the port, for example, might show stronger Anatolian or Near Eastern signals, reflecting a family history tied to the trade routes that were the lifeblood of the Athenian Empire. Similarly, the extensive Greek colonization movement, which had begun in the Archaic period and continued into the Classical, created a vast network of Hellenic communities from Spain to the Crimea. While these colonies were founded by Greeks and maintained a Hellenic identity, they were not established in a vacuum. The colonists interacted, intermarried, and admixed with local, non-Greek populations: Iberians, Scythians, Thracians, and Illyrians. This process worked in both directions, as genetic signatures from these barbarian peoples would have flowed back into the Greek heartland via trade and return migration. The DNA from this era, therefore, tells a dual story. On one hand, it speaks to a profound sense of rootedness and continuity, demonstrating that the cultural identity of the Hellene was built upon a stable and persistent biological foundation. On the other hand, it reveals a dynamic and porous society, one that was constantly absorbing new people and new genetic influences through trade, empire, and colonization. The genetic makeup of the classical Greeks mirrors their civilization, fundamentally rooted in its own past, yet open, expansive, and interconnected. The success of Athens was not due to the arrival of a new, superior population, but rather the ability of the existing population to organize itself in new ways, through institutions like democracy, and to successfully integrate and leverage the diversity that came with its imperial reach, creating a cosmopolitan society whose cultural achievements were built on a resilient and ancient genetic bedrock. The conquests of Alexander III of Macedon in the late 4th century BCE represent a watershed moment in world history, an event that shattered old empires and fused Greek culture with the ancient civilizations of the Near East, creating a new, cosmopolitan world known as the Hellenistic Age. In just over a decade, Alexander's armies marched from Greece to India, toppling the Persian Empire and establishing a vast dominion that stretched across 3 continents. This unprecedented military and political event was followed by centuries of Greek rule in Egypt, Syria, Mesopotamia, and Central Asia, under the successor kingdoms of the Diadochi. This period of intense cultural exchange, migration, and urbanization raises a crucial question for genetic history. How did this massive movement of people, soldiers, administrators, merchants, and colonists, reshape the DNA of both the Greeks and the conquered populations? The genetic legacy of Alexander's conquests is a story of a vast, continent-spanning genetic melting pot. Ancient DNA extracted from remains at Hellenistic sites, from Alexandria in Egypt to Ai Khanoum in modern Afghanistan, is beginning to reveal the human dimension of this historical fusion. The process began with the armies themselves. While led by Macedonians and Greeks, Alexander's forces were a multinational coalition that incorporated soldiers from across his expanding empire. After the conquests, hundreds of thousands of these veterans, along with new waves of Greek and Macedonian colonists, were settled in newly founded cities across the east. These cities, Alexandria, Antioch, Seleucia, became vibrant centers of Hellenic culture, but they were also profoundly diverse, inhabited by Greeks, Macedonians, Persians, Babylonians, Jews, and Egyptians living side by side. In these urban crucibles, intermarriage was not just common, it was in some cases official policy, as Alexander himself famously orchestrated a mass wedding between his officers and Persian noblewomen at Susa. The genetic result was a gradual and complex process of admixture. The DNA of an individual from Hellenistic Alexandria, for instance, might show the classic Greek ancestral profile mixed with significant Egyptian and Near Eastern components. Conversely, the genomes of local populations in Syria or Mesopotamia during this period begin to show a clear, albeit often small, infusion of European DNA, a direct genetic echo of the Greek and Macedonian settlers. This process created new admixed populations across the Near East, people who might speak Greek and participate in gymnasium culture, but whose ancestry was a tapestry woven from both European and Asian threads. The genetic flow was not just one way. As these Hellenistic kingdoms matured, trade and communication routes between Greece and the East became more established than ever before. This facilitated a reverse flow of people and genes back into the Greek homeland. Merchants from Antioch, scholars from Alexandria, and slaves from across the Levant traveled to the Aegean, bringing their diverse genetic signatures with them. As a result, the DNA of the Greek mainland and islands during the Roman period, which immediately followed the Hellenistic era, shows a noticeable increase in ancestry from the Near East and North Africa compared to the Classical period. This was the long-term demographic dividend of Alexander's empire. His conquests initiated a process of bidirectional gene flow that would subtly but permanently alter the genetic landscape of the entire Eastern Mediterranean, making populations on both sides of the Aegean more genetically similar to one another. The Hellenistic period demonstrates that DNA and culture are deeply intertwined but not identical. A person could be culturally Hellenized, speaking Greek, worshipping Greek gods, and living in a polis, without being predominantly of Greek ancestry. The legacy of Alexander, written in the language of our genes, is one of breaking down ancient barriers, creating a world where populations mixed on an unprecedented scale, and laying the genetic groundwork for the even more interconnected world of the Roman Empire that was to follow. It was the moment the Greek gene pool truly went global, leaving a lasting and complex imprint from the Nile to the Indus. The Roman conquest of Greece, completed with the Battle of Corinth in 146 BCE, marked the end of Greek political independence but not the end of Greek cultural influence. As the Roman poet Horace famously declared, "Conquered Greece took captive her savage conqueror." The ensuing centuries of Roman rule, followed by the long millennium of the Eastern Roman, Byzantine Empire, subjected the Greek population to new and powerful demographic forces that would leave their own distinct layers upon the existing genetic tapestry. The initial Roman period brought a new kind of interconnectedness. The entire Mediterranean basin was united under a single stable political entity, the Pax Romana, which facilitated the movement of people, administrators, soldiers, merchants, and slaves, on an unprecedented scale. While Rome admired and absorbed Greek culture, the relationship also involved a significant demographic influx from the Italic Peninsula. Roman officials and their households settled in major Greek cities. Roman army veterans were given land in colonies like Corinth and Patras, and Italian merchants established trading posts throughout the Aegean. While this Latin migration was not a massive folk wandering, ancient DNA from Roman-era burials in Greece reveals a subtle but clear infusion of genetic signatures typical of central Italy. This was not a replacement event, but an admixture that added another thread to the Greek profile, particularly in urban and administrative centers. The true demographic transformation of this long era, however, would come centuries later, during the decline of Roman power in the West and the consolidation of the Byzantine Empire in the East. Beginning in the 6th century CE, the Balkan Peninsula was subjected to successive and large-scale migrations of Slavic-speaking tribes from north of the Danube. Lured by the weakening of the Byzantine frontier, various Slavic groups pushed south, settling vast swathes of the Balkans, including significant parts of mainland Greece. Historical sources, such as the Chronicle of Monemvasia, paint a picture of widespread disruption, with Slavic groups settling in rural areas of the Peloponnese, Thessaly, and Macedonia. For centuries, the extent of this Slavic settlement and its demographic impact has been a subject of fierce debate, often entangled with modern political sensitivities. Genetic research has been instrumental in providing a clearer, more objective picture. Analysis of modern Greek DNA, and increasingly ancient DNA from the early medieval period, has confirmed that this Slavic migration was a major demographic event that left a permanent, albeit geographically variable, imprint on the Greek gene pool. The data shows a clear north-to-south cline of Slavic ancestry in the modern Greek population. In the north, particularly in Macedonia and Thrace, the Slavic genetic contribution is substantial, in some areas accounting for a significant percentage of the total ancestry. This influence gradually diminishes further south. On the Peloponnese, the Slavic signature is present but considerably lower, and on many of the Aegean islands, which were largely insulated from the overland migrations, it is minimal or absent. This genetic evidence refutes two extreme historical positions. It disproves the 19th century theory of Jacob Philipp Fulmeraer, who argued that the ancient Hellenic population was entirely wiped out and replaced by Slavs, but it also demonstrates that the Slavic settlement was far more than just a passing episode or the movement of a few small bands. It was a genuine and demographically significant migration that introduced a major new ancestral component into mainland Greece. The Byzantine state eventually reasserted control and gradually assimilated these Slavic-speaking populations, who adopted Greek language, culture, and Orthodox Christianity. This process of Hellenization was so successful that, within a few centuries, their distinct identity vanished from the historical record, but their genetic legacy endured. The DNA of a modern mainland Greek is therefore a complex palimpsest, bearing the ancient signatures of Neolithic farmers, Minoans and Mycenaeans, layered with influences from the Hellenistic East, the Roman West, and most significantly, the Slavic North. The fall of Constantinople in 1453 marked the end of the Byzantine Empire and ushered in a new era for the Greek-speaking world, one defined by nearly 4 centuries of rule under the Ottoman Empire. This period was one of profound political, social, and religious change, creating a multi-ethnic, multi-confessional state that stretched from the Balkans to the Persian Gulf. A crucial question for geneticists is how this long period of Ottoman domination, with its complex systems of governance and population management, influenced the genetic makeup of the Greek people. Did it lead to a significant influx of Turkish or other non-European DNA, fundamentally altering the Greek gene pool? Or did religious and social barriers keep populations largely separate? The genetic evidence paints a complex and often surprising picture, revealing that despite the long political union, the amount of direct genetic admixture from central Anatolian Turkish populations into the Greek population was remarkably low. The Ottoman system of governance, known as the millet system, played a key role in this. The empire organized its subjects not by ethnicity or language, but by religious affiliation. The vast majority of Greek speakers belonged to the Rum millet, the Roman or Orthodox Christian community, which was granted a significant degree of autonomy in handling its own affairs, including marriage, divorce, and inheritance. This system created strong social and religious barriers that actively discouraged intermarriage between Christians and Muslims. While conversions to Islam certainly occurred, and there were instances of intermingling, especially among the elite, for the bulk of the rural population, life continued within the confines of their religious community. As a result, the genetic integrity of the Greek population was largely maintained throughout this period. Large-scale genomic studies comparing modern Greek and Turkish populations have confirmed this. While they are neighbors and share some deep ancestral components from the Neolithic and Bronze Age, the primary genetic signatures that distinguish the two groups remain remarkably clear. The Central Asian Turkic ancestry, which is a key component of the modern Turkish gene pool stemming from the Seljuk migrations into Anatolia in the 11th century, is present only at very low levels in the Greek population, even after centuries of shared political history. However, the Ottoman period was not without its demographic impacts. The empire's vastness facilitated internal migrations that did lead to more localized and subtle forms of admixture. For example, the Ottomans often moved populations for administrative or security reasons. One significant group were the Arvanites, Albanian-speaking Orthodox Christians who were encouraged to settle in sparsely populated areas of central and southern Greece during the late Byzantine and early Ottoman periods. They were culturally and religiously integrated into Greek society over time, and their distinct linguistic identity has faded, but they introduced a genetic component characteristic of the southwestern Balkans into the regions where they settled. Similarly, the Ottoman Empire was home to diverse populations whose movements could influence the Greek genetic landscape. Sephardic Jews expelled from Spain in 1492 found refuge in Ottoman cities like Thessaloniki, creating a vibrant community. While they largely remained endogamous, some degree of admixture with the surrounding Greek population over centuries is plausible. Furthermore, the institution of the Divserm, the child levy, where Christian boys were taken into Ottoman service, converted to Islam, and became janissaries or administrators, represented a one-way gene flow out of the Christian communities, though its overall demographic impact on such a large population was likely small. Thus, the genetic legacy of the Ottoman era is one of resilience and subtle complexity. It demonstrates that political union does not automatically equate to genetic fusion. Strong cultural and religious boundaries, institutionalized by the millet system, acted as powerful buffers against large-scale admixture, preserving the core genetic heritage of the Greek people. The story written in their DNA from this period is not one of transformation by a new conquering group, but rather one of persistence, punctuated by smaller, more regional movements of people within the vast and diverse framework of the Ottoman world. While the Greek mainland was a crossroads, constantly subjected to the ebb and flow of overland migrations from the Balkans and beyond, the thousands of islands scattered across the Aegean and Ionian seas often served as unique genetic sanctuaries, developing distinct demographic histories shaped by the forces of isolation, maritime trade, and founder effects. The sea, which for the mainland was often a highway, could be a formidable barrier for the islands, insulating them from the large-scale population movements that reshaped the continental gene pool. This phenomenon, known as island biogeography, has created a fascinating mosaic of genetic diversity across the Greek archipelago, where the DNA of each island or island group tells a slightly different story of its past. The most striking example of this is the relative lack of Slavic ancestry on most of the islands compared to the mainland. The large-scale Slavic migrations of the early medieval period were an overland phenomenon. The Slavic tribes, not being a seafaring people initially, were unable to project their presence across the water in significant numbers. As a result, islands from Crete in the south to Lesbos in the northeast, and the Ionian Islands in the west acted as effective refuges for the pre-existing Byzantine Greek population. Their DNA today shows significantly lower levels of the Northern Balkan genetic signature that is common on the mainland. In essence, The islanders' genomes provide a clearer window into the genetic profile of the Greek-speaking world as it existed before the 6th century, preserving an older stratum of Greek ancestry with less subsequent admixture. Crete is a particularly compelling case. As the home of the ancient Minoan Civilization, its genetic history is exceptionally deep. Modern Cretans not only lack significant Slavic admixture, but they also show a remarkable degree of continuity with the Bronze Age inhabitants of the island. Studies have demonstrated a strong genetic link between the modern population and the ancient Minoans, suggesting that the island has been a bastion of indigenous Aegean ancestry for at least 4,000 years. Its size and relative distance from the mainland allowed it to absorb influences – Roman, Arab, Venetian, Ottoman – without erasing its foundational Bronze Age genetic signature. Other islands tell different stories of isolation and interaction. In the Peloponnese, located close to the coast of Anatolia, one finds a greater degree of Anatolian and Levantine admixture, reflecting millennia of trade and interaction with the East. In contrast, the remote and mountainous villages of an island like Carpathos have been shown to be significant genetic isolates, with unique local signatures resulting from centuries of minimal migration and population bottlenecks. Similarly, the unique linguistic and cultural heritage of the Tsakonians in the eastern Peloponnese, who speak a dialect derived directly from ancient Doric Greek, is mirrored by a degree of genetic distinctiveness, suggesting a long history of relative isolation in their mountain refuge. This pattern of isolation also made islands susceptible to founder effects, where a small group of initial settlers contributes a large proportion of the genes to all subsequent generations. This can lead to the overrepresentation of certain rare genetic variants on a specific island. This has made certain Greek island populations, like those in the Hellenic Isolates project, invaluable for medical genetics, as they allow researchers to more easily identify genetic variants associated with complex traits and diseases. The genetics of the Greek islands thus reveal that there is no single Greek DNA. Instead, it is a rich and varied tapestry. The islands acted as living laboratories of human population genetics, preserving ancient lineages, filtering out later migrations, and creating unique local profiles, offering a granular, high-resolution view of the complex and sea-swept history of the Hellenic people. Just as the sea created genetic sanctuaries on the islands, the rugged, mountainous terrain of the Greek mainland provided its own form of isolation, creating inland refuges where ancient populations could persist, insulated from the conquests and migrations sweeping across the more accessible lowlands. Nowhere is this more evident than in the Peloponnese Peninsula, a territory of jagged peaks and secluded valleys that has long served as a bastion of Hellenic identity. The genetics of specific isolated populations within the Peloponnese, such as the Maniats and the Tsakonians, offer a remarkable glimpse into the deep, unbroken history of the region, revealing lineages that have survived in place for millennia. The Mani Peninsula, the central, southernmost finger of the Peloponnese, is a stark and formidable landscape, historically known for its fiercely independent inhabitants and their tower-house settlements. This geographic isolation bred a strong tradition of self-reliance and resistance to outside control, from the Spartans to the Ottomans. Genetic studies have revealed that this cultural independence has a deep biological correlate. The DNA of the Maniats shows a significantly reduced level of the Slavic ancestry that is present elsewhere on the Peloponnese and the mainland. Their genetic profile suggests that they are, to a large degree, the direct descendants of the pre-Slavic medieval Greek population of the region, who in turn descend from the ancient inhabitants. The mountains of Mani acted as a fortress, allowing the local population to weather the storm of the Slavic migrations that transformed the demographics of the surrounding lowlands. This makes them a precious resource for understanding the genetic makeup of the southern Greeks before the early medieval period. An even more extraordinary case is that of the Ciconians, who inhabit a remote mountainous region of the eastern Peloponnese known as Ciconia. Their unique distinction is linguistic. They are the only surviving speakers of a Hellenic dialect that does not descend from the Attic-Ionian Koine of the Hellenistic period. Instead, the Ciconian language is a direct descendant of the ancient Doric dialect, spoken by the Spartans and their neighbors. This linguistic archaism, a living fossil from the pre-classical world, has long fascinated scholars. Genetic research has now shown that this linguistic isolation is mirrored in their DNA. The Ciconians exhibit a distinct genetic signature, showing evidence of long-term isolation with limited gene flow from neighboring populations. Their genome can be seen as a snapshot of the region's Iron Age ancestry, tracing a direct line back to the Doric-speaking inhabitants of the ancient Peloponnese. The survival of both their language and their distinct genetic profile is a testament to the power of geography in shaping human history. Their mountain homeland, difficult to access and of little strategic value to conquerors, allowed them to preserve their unique heritage across thousands of years of turmoil. These mountain populations challenge the notion of a homogeneous Greek identity and reveal a deeper, more complex demographic structure. They demonstrate that while major historical events like the Slavic migrations did have a broad impact, their effects were not uniform. Pockets of the older pre-existing population could and did survive in geographic refuges. The study of these groups provides a crucial baseline, a genetic control group, against which the history of admixture and migration in other parts of Greece can be measured. The lineages of the Maniats and Ciconians are unbroken threads stretching back into antiquity, a powerful biological confirmation that deep within the mountain heartlands of the Peloponnese, the echoes of the ancient Hellenes, in both language and in blood, never truly faded. The genetic story of the Greek people is not confined to the sun-bleached landscapes of the Aegean basin. It is a global saga, written in the DNA of millions who form the Hellenic diaspora. For millennia, Greeks have been a people on the move, establishing communities far from their ancestral homeland and creating a vast, interconnected network that is both cultural and biological. Tracing the DNA of this diaspora provides a unique lens through which to view Greek history, revealing intricate patterns of migration, preservation, and admixture. This outward movement began in antiquity with the great colonization waves of the Archaic period, which established Greek city-states from the shores of the Black Sea, Pontus, to southern Italy and Sicily, Magna Graecia, and the coast of Spain. These ancient diaspora communities were not merely outposts. They were new centers of Hellenic life that developed their own unique identities while retaining a connection to the motherland. Genetically, they represent the first great experiment in Greek admixture. DNA from archaeological sites and modern populations in these regions tells a story of fusion. The Greek colonists, carrying the characteristic Aegean genetic profile forged in the Bronze Age, intermarried with local Italic, Scythian, and Iberian peoples. Over generations, this created distinct new gene pools, such as that found in modern southern Italians, who still carry a significant and discernible layer of ancient Greek ancestry that distinguishes them from their compatriots further north. This genetic legacy, surviving for over 2.5 millennia, is a testament to the demographic impact of this first diaspora. The Roman, Byzantine, and Ottoman periods saw continued, albeit different, patterns of movement, with Greek merchants, artisans, and scholars establishing influential communities in cities like Venice, Alexandria, and Vienna. The fall of Constantinople in 1453 famously sent a wave of Greek intellectuals to Renaissance Italy, a migration that, while small demographically, had an immense cultural impact. However, the largest and most genetically significant chapter of the diaspora story unfolded in the modern era. Beginning in the late 19th century and accelerating dramatically in the 20th, waves of mass immigration were driven by economic hardship, political instability, and the aftermath of devastating conflicts like the Greco-Turkish War, World War II, and the Greek Civil War. Millions of Greeks left their homeland, seeking new lives in the United States, Australia, Canada, and Western Europe. This modern diaspora was fundamentally different from the ancient one. The migrants were not conquerors or state-sponsored colonists but families and individuals seeking opportunity, often arriving with little more than their cultural heritage and their genes. Crucially, these migrants often came from specific regions, villages, or islands, creating a founder effect in their new host countries. Entire communities in Chicago or Melbourne could trace their roots back to a handful of villages in Arcadia or a single island in the Cyclades. This has turned diaspora communities into remarkable genetic time capsules, preserving the specific local genetic signatures of their ancestral regions from the time of their departure. The DNA of a third-generation Greek Australian from Melbourne, for example, might offer a clearer snapshot of the genetic profile of early 20th century Lesbos than the DNA from the island today, which may have experienced more recent internal migration. For the descendants of these migrants, modern commercial DNA testing has become a powerful tool for reconnecting with a heritage that may be culturally distant. Autosomal DNA tests can pinpoint an individual's ancestry not just to Greece, but often to specific regions like the Peloponnese, Crete, or the Pontus, allowing them to trace their family's journey and validate oral histories. Furthermore, Y-DNA and mitochondrial DNA analysis allows them to connect their personal paternal and maternal lines to the grander sweep of Greek genetic history, discovering that their lineage belongs to a haplogroup associated with the first Neolithic farmers, the Mycenaean steppe migrants, or other ancient groups. The diaspora's DNA, therefore, is not a diluted or faded version of the original. It is an archive, a living library of Hellenic genetic diversity distributed across the globe, with each family's genome representing a unique volume that tells a story of resilience, adaptation, and the enduring, unbreakable link to a small, rocky corner of the Mediterranean. The quest to understand the origins of the Greek people has, for over a century, been a complex puzzle pursued by three distinct disciplines. Archaeology, which unearths the material culture of the past; linguistics, which traces the history of their language; and genetics, which deciphers the story written in their DNA. For decades, these fields often worked in isolation, sometimes producing conflicting or incomplete theories. Archaeologists debated the meaning of changes in pottery styles. Linguists argued over the homeland of the Proto-Indo-Europeans, and geneticists, relying on modern DNA, could only make inferences about the deep past. The dawn of the 21st century, however, has witnessed a revolutionary convergence. a grand synthesis powered by the ability to sequence ancient DNA, ADNA. This breakthrough has allowed scientists to directly test long-standing hypotheses, weaving the threads from all three disciplines into a single, coherent, and profoundly detailed historical narrative. The new synthesis has replaced simple, linear models of Greek origins with a more complex and dynamic picture of successive migrations, admixtures, and remarkable continuity. At the heart of this new understanding is the resolution of the coming of the Greeks debate. For years, archaeology documented the stark cultural differences between the Minoans of Crete and the Mycenaeans of the mainland, while linguistics identified Greek as an Indo-European language, implying an origin outside the Aegean. The pieces did not quite fit. Ancient DNA provided the crucial link. By sequencing the genomes of Minoan and Mycenaean individuals, geneticists proved that the Minoans were descended from the local Neolithic Anatolian farmers, while the Mycenaeans were a fusion of this same local population and a new group of people from the Pontic-Caspian steppe. This discovery was the smoking gun. The steppe migrants brought the Proto-Greek language and a warrior culture, which they fused with a more ancient and sophisticated Aegean civilization to create the Mycenaean world, the first Hellenic-speaking society. Suddenly, the archaeological evidence of warrior elites, the linguistic evidence of an Indo-European language, and the genetic evidence of northern admixture all converged on a single, elegant explanation. This powerful synthesis has been applied across the timeline of Greek history, clarifying previously murky periods. The enigma of the Dorian invasion, following the Mycenaean collapse, has been largely solved. While linguistics tracks the spread of the Doric dialect and archaeology shows a societal simplification, ADNA reveals no evidence of a massive, demographically replacing migration from the north. This forces a reinterpretation of the event as a more complex internal power shift or a smaller-scale migration, not the demographic catastrophe it was once thought to be. Similarly, the impact of the medieval Slavic migrations has been brought into sharp focus. Historical texts and Slavic place names across Greece provided clear evidence of their presence, but the demographic extent was fiercely debated. Genetics has now provided a quantitative answer, revealing a clear north-to-south cline of Slavic ancestry in modern Greeks, substantial in the north, moderate in the Peloponnese, and nearly absent on the islands. This genetic data validates the historical sources while precisely mapping the biological legacy of these migrations and the limits of their reach. The modern synthesis, therefore, presents the Greek gene pool as a stratified entity, a geological cross-section of history. The bedrock is the Anatolian Neolithic farmer population that formed the basis of both the Minoan and mainland cultures. Upon this was laid a critical new layer of Bronze Age steppe ancestry, which brought the Greek language and forged the Mycenaean identity. This composite foundation was then selectively modified in the medieval period by a significant infusion of Slavic DNA on the mainland. Subsequent influences from Romans, Venetians, and others added further, more subtle layers to this complex profile. This new unified narrative demonstrates that Greek identity is not a static, monolithic essence, but a dynamic product of history's great forces. It is a braided stream, a story of a people deeply rooted in the Aegean soil for 9,000 years, yet repeatedly enriched and transformed by newcomers who were absorbed and Hellenized, contributing their genes to a constantly evolving biological and cultural tapestry. The ongoing work of integrating these fields continues to refine the picture, promising an even more granular understanding of one of the world's most foundational civilizations. This narrative shows how genetics reveals the deep history of the Greek people, a story of farmers, warriors, and sailors from different lands. Their DNA tells a tale of migration and survival. What parts were most interesting, and how can this story be improved for you? Please share your thoughts.